Okay, so today we start with the last chapter, chapter 16, which is on capacitors. Okay, so what is a capacitor? A capacitor is a device used in a variety of electric circuits, such as electronic noise filtering, remote sensing, to tune frequency in radio receivers. This figure on the left shows a typical design of a capacitor. It consists of two parallel metal plates separated by a distance d and each of area A. Used in an electric circuit, that is when it is connected to a battery, the plates are connected to the positive and negative terminals of a battery or some other voltage source. When this connection is made, electrons are pulled off one of the plates. Okay, so the electrons are pulled off one of the plates and they move, leaving it with a positive charge, and they are transferred through the battery to the other plate, leaving it with a negative charge. The transfer of a charge stops when the potential difference across the plates equal the potential difference across the battery. So again, when connected to a battery or a voltage source, electrons start leaving the one of the plates, leaving it with a positive Q charge, and they move through the battery to the other place, leaving it with a negative Q charge, because now there are excess electrons here, so it is negative Q charge. And the moving of the charge stops when the potential along the plate is equal to the potential across the battery. Okay, now what is the capacitance of a capacitor? The capacitance of a capacitor is the ratio if we have a parallel plate capacitor, the capacitance has to do with the area of each plate and the distance between the two plates. Epsilon here is the permittivity of a free space. It's a constant number. Its value is 8.85 times 10 power minus 12 SI unit. Also, what we have to know that this Q, that is the charge on each plate, is equal to this capacitance that we have just calculated times the V across the battery. So if the capacitance is increased, this Q is increased. If the voltage is increased, the Q is increased. Now, when we have positive charge on one plate and negative charge on another plate, it means there is an electric field moving between these two plates. The value of this electric field, it is voltage divided by the distance. So it is the voltage of the battery divided by this distance d between the two plates. Finally, the energy stored in the capacitor, because most of the time we store energy in this capacitor so as we can use it later for other uses. So the energy stored in the capacitor, we refer to it by U, not E, to distinguish it from the electric field. It is half QV. Q, we can put instead of it CV, so we get half CV squared, or we can put instead of V, Q over C, so we get half Q squared over C. These four equations are to be memorized, and they will be used across this course, this chapter. So let's do one exercise using these four equations. A parallel plate capacitor has an area A, equal to times 10 power minus 4 meters square, and the plate separation D equal 10 power minus 3. Find the capacitance. So the capacitance is, with the formula, it is epsilon times A over D. So this is equal to 8.85. You don't memorize epsilon, we always give it as a given. Minus 12 times A, 2 to the minus 4, divided by D1 e to the minus 3. We get the capacitance to be equal to 1.77 e to the minus 12 farad. Okay, this is part B. How how much charge is on the positive plate if the capacitor is connected to a 3-volt battery? So Q is equal, this is second equation, C times V. This is equal 1.77 e to the minus 12 times V, 3 volts. This will give me 5.31 e to the minus 12 coulomb. Okay. Sorry, I forgot to mention it. The unit of capacitance is farad. We refer to it by F. Okay, so you'll find it here. Farad, we use F instead. Okay. Part B, part C. Calculate the magnitude of the electric field between the two plates. So what is E? E is V over D. This is equal to V is a 3 divided by D, which is 1 e to the minus 3. And this will give me 3000 volts per meter. V is voltage, so it's in volts. D is in this. D is distance, so it's in meter. So the unit of E is V over M. Okay, let's do another one. An air-filled parallel plate capacitor has plates of area A, this much. I have the distance D, this much. And the capacitor is connected to the battery with 12 volts. Okay, so find the value of the capacitor. So again, capacitance, find the value of the capacitance. This is epsilon times A divided by D. This is 8.85 e to the minus 12 times the area is 2 e to the minus 4 divided by D 1.5 e to the minus 3, and this is equal to 1.18 e to the minus 12. Part B, what is the charge? So Q is CV. This is equal 1.18 e to the minus 12 times V, 12. This gives me 1.416 e to the minus 11 coulomb. Part C, what is the magnitude of the uniform electric field? This is E equal V over D. So this is equal to 12 divided by the distance between them, which is 1.5 millimeters. So it is 1.5 e to the minus 3. And this gives me 8,000 volts per meter. Finally, how much energy is stored? So energy U is equal half QV. So this is equal half Q, which is in part B, 1.416 e to the minus 11 times V given 12. This gives me 8.5 e to the minus 11. This is energy, so the unit of it is joules. Okay. Last exercise. Each plate on a 350 picofarad. So picofarad, pico is P. This is 10. This is E to the minus 12, or 10 power minus 12. Okay, so this is pico. So we have the Q. This is given. Q is equal 3750 e to the minus 12 farad. Each plate on okay, sorry, this is picofarad, so this is the capacitance. Okay, carries a charge Q equal 1.75 e to the minus 8 coulomb. Part A, what is the potential difference across the plates? The potential difference, that is V. What is V? V equal what? Okay, so V is potential difference. So I will use Q equals CV, which gives me V is equal Q over C. This is equal 1.75 e to the minus 8 divided by 3750 e to the minus 12, and I get 4.67 volts. Part B, if the plates are 6.5 e to the minus 4 meter apart, what is the magnitude of the electric field? So E is V over D. This is 4.67 divided by 6.5 e to the minus 4, and this is 7180 volt per. Okay, so this is the last exercise. So for a parallel plate capacitor, we calculate the capacitance. It is epsilon 0 A, which is the area of each plate, divided by D, which is the distance between them. The unit of the capacitance is farad. We calculate the charge on each of the parallel plates. It is C times V, where V is the potential difference or the voltage across the battery. The electric field between the two plates, E, is V over D. And the energy stored is half QV, or if I put instead of QCV, I get half CV squared, or if I put instead of V Q over C, I get half Q squared over C. Okay, so this is it for this lecture.